Dear students, in the previous class we discussed about the SN1 mechanism, that is by taking the example that is hydrolysis of form, that is tertiary butyl bromide. In this class we are going to be discussing about the SN2 mechanism. To study of this SN2 mechanism, we are going to be taken the example that is hydrolysis of methyl bromide. Hydrolysis of methyl bromide means here the methyl bromide is going to be treated with is going to be heated with that is the aqueous KOH and the aqueous NaOH. Aqueous KOH or aqueous NaOH is going to be used the methyl alcohol. It's going to be used the methyl alcohol. This reaction undergoes the SN2 mechanism. This reaction undergoes the SN2 mechanism. We'll take the see the reaction, that is I said that the hydrolysis of methyl bromide. The methyl bromide means that is CH3Br. This we called as a methyl bromide. This is we are going to be treated heated with the aqueous KOH is going to be used the methyl alcohol. That is methyl alcohol. Plus Kb. This is about the example. This is about the example for the SN2 reaction. There is a mechanism we are going to be studying now. There is in the mechanism. This mechanism undergoes in only one step because of that is the electron releasing capacity of the methyl group. The electron releasing capacity of the methyl group. The carbon acquires a partial positive charge. When it acquires a partial positive charge, the nucleophile, that is OH minus nucleophile, attacks the this carbon. Means that is if you are going to be taken the methyl bromide, that is methyl bromide. This is about the methyl bromide. This methyl bromide, the OH minus, this is the nucleophile. Nucleophile attacks the carbon. Why it is attacks the carbon? This gets the positive charge. Electron releasing capacity of the methyl group. The carbon gets the positive charge. This is going to be attacks the carbon, which is opposite to the that is bromide ion. Why it is going to be attacked the opposite side? Because of the that is to avoid the repulsion between the OH minus and Br. OH minus and the Br. This due to this is going to be attacks the carbon opposite to the that is Br attached to it. Then it's going to be formed in transition state. It's going to be formed the transition state. Means this when it attacks the OH minus to the carbon, 3 hydrogen atoms attached to the carbon lies in the one plane. These 3 hydrogen atoms attached to the carbon lies in the one plane, and these OH minus and Br is going to be OH and the Br is going to be partially bonded to the carbon. This state we called as a transition state. This transition state is unstable. Means there is the bond between the carbon and the bromide is going to be weakens. The bond between the carbon and the OH, that is going to be increased. The strength of this bond, strength of the bond between the that is the carbon and the OH is going to be increases. The strength of the bond between the carbon and the bromide is going to be decreases. At that time, it's going to be used the giving group, that is bromide ion. It's used as a bromide ion and it forms a that is methyl alcohol. It's going to be methyl alcohol. Then in this you can observe that is the product form is inversion in configuration. The product form is inversion in configuration. This mechanism we call as a SN2 mechanism. This mechanism we call as a SN2 mechanism. Now in the previous class we discussed about the SN1 mechanism. In this class we are going to discuss about the SN2 mechanism. We will be studying now the differences between this SN1 and SN2 mechanisms. When it comes to that SN1 and SN2, that is SN1 mechanism, that is about the SN2 mechanism. That is the difference between these two means the SN1 mechanism follows the first order kinetics. First order kinetics. This almost all that is the SN2 reaction is going to be follows the second order kinetics. Second order kinetics. Then in the SN1 reactions, that is the product form is both inversion and retention in configuration. The product formed in that is SN1 mechanism, in SN1 reactions, that is is both inversion and retention in configuration. In this SN2 reaction, that is only inversion in configuration. Inversion in configuration means you can observe the attack of the nucleophile is opposite to this living group, opposite to the living group attached. You can observe means always it's going to be found that the only inversion in configuration. Inversion in configuration. This is about the another differences between this another difference between the SN1 and SN2 mechanism. Now the reaction rate determined by the polar factors in that is SN1 mechanism. In the SN1 mechanism is going to be the reaction rate is going to be depends on that is the SN polar factors. In the SN2 we are going to be discussed about the reaction rate mainly determined by the steric factors. Is going to be steric factors in that is in the SN. This is about the polar factors, which is and the rate is going to depend on polar factor. This is about the steric factors. Then order of reactivity in the SN1 mechanism is tertiary. Order of reactivity of the alkyl halides tertiary is more reactive than secondary. Secondary is more reactive than primary. Primary is more reactive than the methyl halide. That is this SN2 mechanism. The methyl halide is more reactive than primary, then secondary, then tertiary. This is about the order of reactivity of the alkyl halide. This is about the differences between the SN1 and SN2 mechanisms. Here, very important for the examination purpose, that is SN1 mechanism and SN2 mechanism. There is about the differences in this SN1 and SN2 mechanism. Once again, we will be recall just the differences between the SN1 and the SN2 mechanisms. The SN1 mechanism follows the first order kinetics, and SN2 there is reactions going to be reactions or mechanisms going to be follows the second order kinetics. In this both inversion and retention configuration, the product formed is both inversion and retention in configuration. The product formed in SN2 reaction is only inversion in configuration. Then this the rate is going to be depends on the polar factors. Then this about only on the steric factors. Then order of reactivity of alkyl halides is going to be tertiary. Alkyl halides controls the SN1 mechanism in the faster rate, that is than the secondary, primary and methyl halide. Then methyl halides controls the SN2 mechanism in the faster rate compared to the primary and secondary and tertiary. This is about the difference between in the SN1 and SN2 mechanisms. Then this about next we are going to discussing about this factors. Now we are going to be discussing about the stereochemical aspects of nucleophilic substitution reactions. Until now we have discussed about the SN1, SN2 mechanisms. Now we are going to be discussing about the stereochemical aspects of these reactions. When it comes to the nucleophilic, that is the stereochemical aspects, we know that what is meant by isomerism. Isomerism means two or more compounds having the same molecular formula, but different in the physical and the chemical properties. That we call as a isomers. The phenomenon is called as a isomerism. The phenomenon is called as a isomerism. Isomerism means two or more compounds having the same molecular formula, but difference in that is the physical and the chemical properties. Physical and chemical properties that we call as a isomerism. There are two types of isomerism. In that isomerism, there are two types of isomerism. Now we know that what is the definition of isomerism. The isomerism having the two types. That is the structural isomerism. Structural isomerism. The second one we call as the stereoisomerism. This structural isomerism means this already in first view we have discussed about the structural isomerism. Structural isomerism means two or more compounds having the same molecular formula but differ in the structure. That we call as a structural isomerism. And now we are going to be discussing mainly about the stereoisomerism. The stereoisomerism means two or more compounds having the same molecular formula, same structure, but differ in the arrangement of atoms or groups around the atom. That we called as a stereoisomers. The phenomenon is called as a stereoisomerism. There are two types of stereoisomerism. The one we called as a optical isomerism. One we called as optical isomerism. Another we called as a geometrical isomerism. One we called as a optical isomerism. Another one we called as a geometrical isomerism. Now we know what is meant by stereoisomerism. Stereoisomerism means the two or more compounds having the same molecular formula and structure but differ in the arrangement and the spatial arrangement of atoms or the groups. That we called as a stereoisomers. The phenomenon is called as a stereoisomerism. That stereoisomerism, there are again two types, that is the optical isomerism and the geometrical isomerism. Before going to the study of this optical isomerism, we should study a few terms related to this the optical isomerism. What is meant by plane polarized light? Plane polarized light. Plane polarized light means plane polarized light means according to wave mechanics. That is the ordinary light is going to be the beam of ordinary light is going to be propagates in all directions, which is perpendicular to its propagation, perpendicular to the direction of propagation. Therefore, a beam of ordinary light is going to be passed through the Nicol prism. The emergent light is going to be vibrates in only one direction. That we call as a plane polarized light. Means the light which vibrates in only one direction. That we call as a plane polarized light. Then what is meant by optical activity? Now we are going to study about the optical activity. Optical activity means some compounds, some organic compounds, the solutions of some organic compounds can rotate the plane polarized light. The solutions of some organic compounds can rotate. It's going to be rotate either left or right. Left or right. That we called as a that compounds we called as a optical compounds. The phenomenon is called as a optical activity. The phenomenon is called as a optical activity. Means optical activity means some solutions of organic compounds can rotate the plane polarized light either left or right. That compounds we called as a optical compounds. That we called as a optical compounds. The phenomenon is called as a optical activity. Optical activity. In this, now we are going to be what is meant by optical activity. We know plane polarized light. We know. Then we are going to be study about the now optical isomerism. In this, optical isomerism. What is meant by optical isomerism? Means two or more compounds having the same molecular formula, but differ in the rotation of plane polarized light. Rotation of the plane polarized light. That we called as a optical isomers. The phenomenon is called as a optical isomerism. The phenomenon is called as a optical isomerism. In this, we'll take some example. Lactic acid. We'll take the example that is lactic acid. When we are going to take the example lactic acid, that is COOH, then CH. This is about the lactic acid. This we called as a, this is going to be indicated by the minus lactic acid. This we are going to be. Then another one we are going to be represent, that is C. This we call that it is going to be represented by plus, that is lactic acid. Means in this, suppose the lactic acid, we took the example lactic acid. If you are going to be, the plane polarized is going to be passed through the lactic acid, it rotates to right. That we called as a dextrorotatory. It's going to be indicating by the plus sign. It's going to be indicating with the plus sign. If suppose the we are going to be passing the plane polarized light to the lactic acid, it rotates to the left. That we call as a, that is levorotatory. This we call as a levorotatory. Means the compound which rotates the plane polarized light to right, that we call as a dextrorotatory. The compounds which rotates the plane polarized light to the left, that we call as a levorotatory. Dextrorotatory is going to be indicating by plus sign. Then levorotatory is going to be indicating by the minus sign. This is about the optical isomerism. Means in this, these are mirror images. But not superimposable. Means the optical isomerism means the compounds having the same molecular formula, but it rotates the plane polarized into different directions. That we call as a optical isomerism. In this, we are going to be discussing about the some other things. That is, we are going to be indicating that minus sign to the levorotatory, plus sign to the dextrorotatory. This is about the optical isomerism. Plane polarized light means the light which vibrates in only one direction, that we call as a plane polarized. How to get this? By passing the ordinary light to the Nicol prism. We are going to create the plane polarized light. Then optical activity means solutions of some organic compounds can rotate the plane polarized light to the left or right, that we call as a optical compounds. The phenomenon is called as a optical activity. Then the next optical isomerism means the compounds having the same molecular formula but differ in the rotation of plane polarized light, that we call it as a optical isomerism. In the optical isomerism, the dextrorotatory, levorotatory. Dextrorotatory means towards the plane polarized light is going to rotate to the right. This is going to be rotates the left. That is, dextrorotatory means the plane the compounds which rotates the plane polarized to the right. That we call as a dextrorotatory. Then the compounds which rotates the plane polarized to the left, that we call as a levorotatory.